We'll do a short screencast on long division because this is a technique that is new to AP Calculus AB. It allows us to integrate a few functions that we don't know how to integrate yet. So long division is a technique for dividing numbers, and can also be used to divide polynomials. So in the example here, this is the dividend, this is the divisor. We are only practicing long division. We are not talking about integration yet. So the technique is like that. You would write the dividend here, the divisor here, and the question you always ask is how many times can you put x squared into 2x cubed? And the answer is you can put it 2x times. So 2x times x squared equals 2x cubed, and 2x times 1 equals 2x. So 2x cubed plus 2x. And I aligned 2x with 5x vertically. Now we subtract this from the line above, and we find negative x squared plus 3x minus 4. And we repeat the process. How many times can I put x squared into negative x squared? And the answer is negative 1. So 2x minus 1. And now I will multiply negative 1 by x squared and by 1. So it's negative x squared minus 1, which I subtract from the line above, and I am left with 3x minus 3. This is called the remainder, and we can't go further because x squared has a larger degree than 3x. So the conclusion is that our original expression here, 2x cubed minus x squared plus 5x minus 4 over x squared plus 1, is equal to the quotient 2x minus 1 plus 3x minus 3 over x squared plus 1. Now, how can we apply that to calculus and integrals in particular? If we have a question such as this one, we wouldn't be able to integrate it immediately, but we can try long division. It won't always work, but obviously in questions that we will ask or be asked on the AP exam, it probably will. If U substitution doesn't work, this is another option for you. So I'm not going to go through the details of the long division. It's a method that you've learned a long time ago, but here is what happens in this case as we figure out how many times x goes into x cubed, etc. We find ourselves with a quotient of x squared plus x plus 4 and a remainder of 0, which in fact means that this expression is just the integral of x squared plus x minus 4. There isn't even a remainder over the divisor. So this is very easy. It's a polynomial of degree 2. It's very easy to integrate, and there is the answer. So what seemed almost impossible 2 minutes ago happens to be pretty easy in the end if we use long division. Example B will show us another case where there is a remainder. So once again, I'm not going to go through the details of long division. Here it's very short. 2x multiplied by 3 equals 6x, so I subtract 6x minus 3, and I'm left with a remainder of negative 2, which means that this is equal to the integral of 3 plus remainder over divisor. So going one step further, I can break this integral into 2. I have the integral from 1 to e of 3 dx minus 2 times the integral from 1 to e, I forgot to write it here, of 1 over 2x minus 1 dx. And we've just seen, well, the integral of 3 is 3x. We just saw very recently how to find the integral of 1 over 2x minus 1. It will involve a logarithm. We have to fix it a little bit by multiplying by 1/2. But anyway, once we are here, we plug in e minus plugging 1, and we get to the answer. So really, once we've done long division, we just need to be aware that we will have to maybe use other techniques that we've learned in previous sections, like here 1 over 2x minus 1. In even more difficult cases, it may happen that you would need to do a u substitution here. That's it. Thank you very much.